Good afternoon everyone. Today we are here to solve a numerical problem from previous year question paper of IC engine and gas turbine. We solve a dual combustion cycle numerical problem. This is a very good example. So, before solving the problem, we have to understood what is actually the dual combustion cycle, what is the PV and TS diagram. So, we have to understood the PV TS diagram first. So, basically this is the PV and TS diagram of a dual combustion cycle. So, here we can see that there is some processes like from 1 to 2, from 1 point to 2 point. This is, you can see that here is isentropic compression is there, isentropic compression is there. After the point 2 to 3, this is the constant volume heat addition process. Why constant volume heat addition process? Because it is the straight line along the axis V. So, it is a constant volume heat addition process. Next 3 to 4 is the constant pressure heat addition process. Constant pressure heat addition process because here pressure is not changed, that is why the constant pressure heat addition process. So, in here 2 to 3 and 3 to 4 there is Q input. Q input means the total heat or total heat is input from the process 2 to 3 and 3 to 4. Then 4 to 5 is isentropic expansion, again it is not straight line. So, it is an isentropic expansion process. Then 5 to 1 is constant volume heat rejection process. So, we have understood the scenario of the PV diagram and also the TS diagram of the dual combustion cycle. Here we can see that in TS diagram here V is equal to constant, and in there 2 to 3 and P to 3 to 4 where pressure is equal to constant. So, now what is the problem? The problem is in an engine working dual cycle, the temperature pressure at the beginning of the cycle are 900 degrees centigrade and 1 bar, and the compression ratio is 9. The maximum pressure is limited to 68 bar, and the total heat supplied per kg of air is 750 kilojoule. So, what is the determine? The determine is the pressure and temperature at all salient points. So, first problem is pressure and temperature at all salient points. Salience means the noticeable point, that means 1, 2, 3, 4, 5, that is the pressure and temperature in all salient points. So, what is the pressure? So, first in the given data we have see that the temperature is given, that is 900 degrees centigrade, and the pressure is 1 bar. So, from the given data we can write that T1 in at point at the starting of the circle, and the one point T1 is 900 degrees centigrade, 900 degrees centigrade. So, that means 900 plus 273 Kelvin means 1173 Kelvin, and the P1 is 1 bar, and P1 is 1 bar. Next, number 2 point. In this point, number 2 point, what is happening at the end of the isentropic compression, means at the end of the compression process. So, number 2 is end of compression, end of compression process, end of compression process. So, in the end of compression process, what will be the temperature? That means T2. In the 2 point, I have considered the point 2, that is 2 point, T2 is equal to T1 into R to the power gamma minus 1. Here R is equal to, here this R is the compression ratio, R is equal to compression ratio, which is given in the data, that is the 9, that is 9 is given here, that is 9. Okay. And another thing is gamma is equal to 1.4, 1.4 adiabatic index, air adiabatic index. So, 1.4 is R gamma is 1.4 and the R is compression ratio which is given in 9. So, if we solve the problem, it is T1 means it is 1173 here, 1173 into R means here 9 to the power 1.4 minus 1. So, what will be the temperature? The temperature will be 581 Kelvin, 581 Kelvin. You should check that's the what is the actual numerical value, is it is 581 K or not, you should check. Okay. After that, so it is the T2, T1 we have got the T1 value and T2 value is there. So, after that point 3 and point 4, 2 to 3 and 3 to 4. The process 2 to 3 and 3 to 4 is heat addition process, heat addition. So, it is heat addition process. So, in that case end of heat addition is done in point 4. So, end of heat addition T4 is equal to 1750 by Cp. And what is 1750? You can see that the total heat supplied Q in is equal to 1750 kilojoule, which is given, and the Cp of air is 1.005 kilojoule per kg is here. So, total heat supplied is 1570 kilojoule per kg of air is 1.750. What is total heat supplied, and Cp is 1.005 kilojoule per kg. So, 1750 by 1.005. The answer is 1745 Kelvin. 1745 Kelvin. That is another answer. So, in that point the temperature T4 is that, and the pressure P3 is equal to P4 because it is a constant pressure heat addition process. So, P3 because it is a 3 and 4 is constant pressure heat addition process. So, P3 is equal to P4 is equal to 68 bar. It is also given in the given data. Okay. So, next at the end of compression, expansion process, because the 4 to 5 is isentropic expansion process. 4 to 5 process is this 4 to 5 is isentropic expansion process. So, at that point T5 is equal to T4 into 1 by R to the power gamma minus 1. Here, because this is a expansion process, so it is 1 by r and the gamma minus 1. Gamma minus 1 is the gamma is the air adiabatic index. So, if we put the value here, T4 and the r value and the gamma value, that will be 1745, that will be determined in previous, that 1 by r is equal to 9, 1.4 minus 1, that is the answer will be the 844 Kelvin. The answer is will be 844 Kelvin. This is the another answer which will be, which is T5 at the point 5. Now P5, that means pressure at the salient point 5 is P4 into 1 by r whole to the power gamma, P4 into 1 by r whole to the power gamma. That means it will be P4 will be 68 bar, which will be given in the given data, and 1 r is equal to 9 to the power 1.4. So, the answer will be 1.45 bar. The answer will be 1.45 bar. So, it is the pressure, salient pressure at the point 5, in the salient point 5. The pressure is pressure at the salient point 5. So, it is another answer. After that we have to find out the next part is air standard efficiency, B, air standard efficiency. What is the air standard efficiency? We have denoted the efficiency is eta air is equal to 1 minus 1 by r whole to the power gamma, 1 minus 1 by r whole to the power gamma. So, 1 minus 1 by r is 9 whole to the power 1.4, that means 0.599, or you can say 59.9%. This is another answer. This is another answer of air's standard cycle efficiency. So, eta air is 1 minus 1 by r whole to the power gamma. 1 r is compression ratio here, the 9 and the gamma is 1.4. From there we can calculate the value that the air standard efficiency is 0.599 or 59.9%. Now, we are going to the final part of the question, that is the mean effective pressure. That is the mean effective pressure. What is the mean effective pressure? The mean effective pressure means the P4 minus P5 by 1 minus 1 by r. So, what is the P4? We have already calculated the value, we have to put the value here and we can get the mean effective pressure is 44.6 bar. We have to check the value, you have to check the value, and you have to see that this value will be 44.6 bar in the final question.